Welcome back to Physics with Miyoshi. Today I want to talk about physics or kinematics in two dimensions. Kinematics in two dimensions is very similar to what we've done already with kinematics in one dimension. Now we just have a second component. So instead of just d, we would look at the x and the y. Instead of the v, we would have x and y components of vectors. And that's really the main thing. We look at everything, and whether it's displacement or velocity or acceleration, and now we look at it all in terms of vectors. For instance, you might have a hockey puck on ice, or that has no acceleration on it, or you might have a spaceship in space, and you might have a displacement or a velocity, and we might have something like this example, or maybe I have a 30 degrees I have a velocity, initial velocity of 10 meters per second, and I know that this goes out in the x and the y direction, and maybe I know that this guy travels for 10 seconds, so its final velocity would be equal to its initial velocity. Oopsie. Because there's no acceleration. How far did this guy get displaced in a problem like this? Well, if we know the time is 10 seconds, for instance, we can see that this guy has to go, well, let's use 15 instead. 15 seconds. We can see that it went 150 meters to get here, but it's along this line here. So this d would be velocity times time. So that would be 150, well, that would be 15 seconds times 10 meters per second would give me 150 meters in that same direction. Well, in most cases, it's not going to be that simple. We would want to find the displacement in the x direction and the velocity in the x direction. So we might want to find the dx and the dy. And this is just notation. And then we would want to find the vx and vy in most cases. So to do that, we would have to remember that just our little vector here, or our breaking up of our vector into components, we could see that this would be v0. Our vx would be down here, and our vy would be here. So, and here's our theta. So we know that cosine, and again, I would draw the picture always instead of relying on saying that cosine is vx and sine is vy. If I could do cosine of theta is vx over v0, and sine of theta is vy over v0. This would also work for dx, d, and dy, d. Okay, so in the case of dx, I would have dx, I'd rearrange this equation, and we'd see that dx is cosine, d times cosine theta, or in this case 30 degrees. dy is d times sine of 30 degrees. And I could find those, and I could do the equations, the math, and this ends up being 8.66 meters, and this ends up being, should be half, 5 meters. This guy here, the same. Likewise, we would have vx is v0 times cos theta, and vy is v0 times sine theta. Again, doing the math, we know that this guy should be, what should it be? 129.9 meters, because I multiply v, oops, did I do that wrong? I think I did that wrong. I did. This should be our vx, vy, dx, dy, d and d. This is v0, v0. So, sorry if I confused you a little bit there. That should be then dy, d, 150 meters times that guy, that's 150 meters, times the sine of theta would give me 75 meters. Okay? So these are some simple, a very simple equation in kinematics in 2 dimensions, and this is usually not what we have. Most of the time what you're going to have is what we would call projectile motion. And in projectile motion, there's a couple things you can do to help yourself out. First of all, don't take too much time drawing your little picture. But we would have something like this where we want to know, maybe we want to know the height, or we want to know the distance. We'll probably want to either know the V0, or maybe we know the Vx, or the Vy. And sometimes we'll have a little h, a height distance here, or even a drop below there. It could be a height, but these are equations that we often find where we know some of these guys and don't know others, and we want to find them. The trick here is actually very simple. Normally, you're going to use the y, since we know that gravity is affecting it usually. So you want to find something to do with the time when we are in the y direction. And then in the x direction, normally what we want to do is we would usually use the fact that there's, or the assumption that there's no air resistance, and that way the Vx would always be constant. And so usually you would use this guy to find the range, knowing that there's no air resistance. Oops. So we'll get rid of the air resistance, and then we can find the range because we know that the velocity in the x direction is the same as the final velocity in the x direction. Okay, so just a couple of things to remember and how to use vectors. If we can use vectors, then we can find components. We can do most of the things in two-dimensional kinematics very simply just by doing 2 problems of single-dimensional kinematics. So I'll give you some more equations, or give you a couple more problems in kinematics in 2 dimensions, but remember, it's really just breaking up the problems into 2 single-dimension problems. So thanks for tuning in, and we'll see you back next time with Physics with Miyoshi.